Hey everybody, this is Alex Merced from alexmercedcoder.com. This is another video on Scala. In this video, what I like to do is get into sort of writing functions that return a value, and also working with collections. So working with arrays, lists, and then I think a map will be our key value pair. We'll explore the different types of things. Again, I'm making this video series not just to show you how to use Scala, but I'm actually learning how to use Scala as we do this. This is the way I find is effective for me to learn, because by teaching, it forces me to really think through what every little thing I do is doing, so that way I can articulate it. And then the more I do that, and the easier it is to learn the next thing incrementally. So I generally always recommend people to also create blogs and make videos as they learn. There's nothing wrong with just being being transparent about your process. Okay, so let's see here. First, let's write a function. Now, before, again, I was a little weirded out when I was watching the pattern matching feature, and I said that equal sign of function. Turns out, if a function returns a value, that's where that equal sign comes into place. So, for example, if I want this thing to return a string, so we'll say let's make this function here. And again, how you define a function is you use the def keyword, and then we give the function a name, and then I can define any arguments. So we'll just say num, which is going to equal an int. And then I'm going to want this to return an int. So that's how I type the return value. The return value comes. So that's a little bit different than if you're using this is actually very common in newer type languages, like if you use TypeScript or Go or Rust, having sort of the type of the return value over here. Versus if you use C, C++, I think even Java, the return value is actually instead of you declaring something with a keyword like def or func or something like that, you would actually just include the type up front, the type of the variable, the type of the return value of a function, something like that. I kind of like this way better. I like having the keyword to make it clear that I'm defining a function. Yeah, that theoretically might be a few more keystrokes, but we save keystrokes elsewhere, and I find this to be a little bit more explicit, a little bit clear for me when I'm reading code. So I can understand very easily that this is taking one argument that is an integer and returning an integer in return, and that's pretty clear. Okay, but in that case, what I have to do is but in this language, which I think is also the case in OCaml, when I type that, so when I say, okay, hey, this returns an int, I have to write equals afterwards. So essentially, the returned integer equals the result of this block. And again, you can kind of in JavaScript, I think you can forego the curly brackets if you're immediately returning whatever the next value is. So for example, if I did this and just said, hey, it returns num, okay, I think that should work. So let's try this out. Okay, we'll just say val y equals the result of hello. We'll pass it the number 5. And so theoretically, if that worked, hello should return 5, because I'm saying it's going to return an integer. And since I didn't use curly brackets, it's an implied return, kind of like that match statement that we looked at in the previous video. So that it should just return num. Okay, which in that case should be 5. So y should equal 5. Print line y. Okay, so if my thinking is correct, again, this is how you learn. You learn the thing, you make some assumptions about what the thing should do, and then you test those assumptions out. So that way you know if you're right or wrong. Okay, that way, and that's generally how I've been able to learn as much as I have in the relatively short time I have. Because if I'm not sure about something, I just try it out, just to see hey, does this do what I can do? I'm not gonna break anything. Just try it out in small little doses. Okay, I'm not writing such a complex program that if it doesn't work, it's going to take me forever to debug and figure it out the right way. It's something simple, and I can test it out. So again, let's compile the code. So we compile the Scala file. And then let me go run the script. And yeah, that's exactly what it does. Okay, so you return the value of 5. Or else this wouldn't have printed here. So you could write pretty succinct functions. So you see that function's pretty straightforward. Okay, now I could make it a little bit more interesting and do num times num. So it's going to return me the square of whatever number I pass it. So in this case, if I compile this again, it should return me 25. Oops, I compiled it twice. Okay, see I get back 25. Okay, so that's cool. But again, functions can oftentimes be more complicated than that. So in that case, we will use the curly brackets, and then in the curly brackets we can do stuff. Okay, cool. And here also, just another thing to be aware of is that I can actually pass it a named argument. So let's say I had num1, num, and num2, which is also an int. Okay, I'm giving the arguments a name and a type. So now I can do this. I could say, let's say I want to print line. Let's say here num. Okay, num. And then we'll just say here we're going to print num. And actually the way I should do this, because I don't think I can quite do it exactly like that. Let's talk a little bit about interpolation in so the way you can do interpolation here, if I remember correctly, if you want to do a format string, you can use f just kind of like Python. And then what you have to do is you have to use certain format string operators. So like in lower level languages, C, C++, interpolation is a little bit more complicated because you have to use operators in your string that kind of designate the type of data it's interpolating into the string. So in this case, I think it's %d. So we'll say num is %d, which means a digit. And then I can pass in as an argument anything that would require. And because I put this f, you could also use a function called printf, but I think they later on added this to Scala, so I can use this like f, make it an f string, kind of like, again, like Python. Again, a lot of people who use Python use Scala and vice versa, because data. Fnum is %d, and what am I thinking here? Num is %d, and I want to put num here. Then I will do this again. Printf. Actually, I just have to copy it. Let's save ourselves some time. Okay. And then we'll say num2, and then this is going to be num2. Okay. And then it needs to return a number, so we'll say return num plus num2. Okay, so there's our function. Now what I'm going to do here is instead of just passing in the number 5, I'm actually going to say num2 is 6 and num is 4. So notice I'm passing them in reverse order. In normal functions, when you don't have named arguments, basically the first argument would be go inside the first parameter. Okay, so basically the 6 would have been saved inside the num argument, and 4 would have been saved in the num2 argument. Because they have names, and I referred to them by their name, it should be 6 should still get stored in num2, and 4 should still get stored in num. Okay, so that's neat. That's one of the things that just seems to always have been missing in JavaScript, although it's easy enough to like simulate in JavaScript, because I mean you have named arguments. I think you definitely have them in Python. I'm pretty sure you have them in Ruby. Let me just double check that. Do we have named arguments in Ruby? Keyword arguments. Yes, we do. Cool. So yeah, generally most languages do. Even lower level languages, but JavaScript, you can pretty much do the same thing by using a JavaScript object as the argument. I just find that while that works, oftentimes people have a hard time wrapping their head around that one. Even though it's not that complicated, it's just, especially for like new developers, a lot of things maybe just seem tricky. Okay, so let's try this out. Ensure that it works. So let's compile the program. Oh, didn't like that. So let's see here. What does it not like? Okay, it doesn't like the way I wrote that. I have a feeling that probably I'm not using a colon there. I'm probably going to be using a. So let's see here. Where? No, def add int. Let's see here. Where's the thing on named arguments? Here we go. Name function is called by name. Variable arguments. Nested functions. Here we go. Functions with named arguments. Okay, let's just see here. Oh, yep, you're using an equal sign, not a colon sign. That always gets different. It's different from language to language, so I just forget which is which. But actually, I think this is more consistent where it's the equal sign. Same thing in Python. So let's run that. Let's compile that again. Too many arguments for method println x and a unit. Println f2 is the error. Too many arguments for method println. Okay, I think well, I'll just do the easy way out, where I'll just use f there, because I think I have to save the f string in its own variable. Let's actually try that out for the second one. So let's keep that println, and instead I will take this, Control X, and where did I see the f string thing? Concatenate strings. Yep, we can always add strings together. That's fun. But we want to see the version with the, here we go, the f interpolator. 2. Yeah, you could technically do that. But I gotta include the variable name and the type. That's the deal. Okay. So in that case, what I would want to do is just go back. If I want to do that, I'd have to include num here. So I would do $num. And then here I would do $num2. And there would be no second argument. Not for println, but I can pass this formatted string. So that would be how that would work. Again, it's the variable name, and then you do the appropriate interpolation operator. Okay, if not, you'd have to do it with printf. And printf, then you would do it the way I kind of did before, where I had the string and then added the additional arguments. So just to kind of show that, I'll show it both ways. So in that case, we'd have a string here. And then this would be like num2. Okay, so then num2 gets injected here by this printf function. Although I think I'm going to want a new line character there, because I don't think, see, println always adds, in any language, always adds a new line character at the end of the string, so it always will skip to the next line for the next output. I don't think printf does that usually, so I'm going to put a new line character at the end there. So that way it skips to the next line. Okay, so let's try that again. Let's compile. And so far these errors are actually pretty decent. Like, one thing I judge when I use a new language is the quality of the errors. Like, do the errors tell me what I need to fix? I love Rust for that because it has really, really, really detailed errors, but it's also really, really hard. So it's like it's a weird balance with Rust. I like this. Like, the language itself isn't too hard, but the errors so far have been pretty descriptive. I haven't had a hard time understanding them. So far, this language has not been bad at all. Okay, so now let's run this script. Okay, and see num is 4, which is exactly what we said, and num2 is 6. So even though I put them out of order, then the way I declare my arguments in the function definition, they still get accepted in the right order because I explicitly said their name. So that's pretty cool. Okay, so I think we've played enough with functions. Now let's start dealing with like an array. And again, array here are going to work with like a parentheses. So let's just see here. If I were to do like x, let's do var x equals, and then I think if I want to just declare like a new arbitrary array, I would just do a parentheses and I would do like 1, 2, 3, 4, 5. So there I'm declaring a new array, but again, the array is a fixed length. So let's say I do another array, so var y, which equals 6, 7, 8. Nope, that's gotta be in parentheses. 6, 7, 8, 9, 10. First, just loop over 1. So just to show you that the items are in the array. So for z of x, so for every z in x, let's print line z. Okay, and let's see. Hopefully, it doesn't complain that there's an unused function. Nope. Actually, nope. Let's compile. Okay, value for each is not a number. Value for each an array. Okay, so maybe that wasn't an array. Yeah, no, you. Oh, I gotta write the word array in front of it. Ah, so you gotta do that. Now that should work. Good. That's the one thing I like about compiled languages is that if it compiles, you know it's gonna run. I mean, you might have other logical errors that, your code will be, you're syntactically fine, but you just logically thought of something wrong. But at least I know, like, hey, there's no going to be, like, no runtime errors if it compiles. Okay. I mean, well, let me take that back. There might be runtime errors, but they're going to be, like, not typical. Okay, so see, I loop through the array, but again, just because the arrays have a fixed length doesn't necessarily mean it's impossible for me to like work with them. So if I wanted to create this into one big array, I could do like var h equals, and I think it's like concat. Let me just go double check that method name. Concat. Here we go, concat. All arrays into a single array. Okay. Let me see an example. Here we go. Concat. Yep. Okay. So I would just do like concat, and then I would just, and I think this is pretty much the same in C. X and Y, and then let's loop through that. So let's again do Z of H, and let's just print line Z, and that, let's compile that. I found again error not found value concat. Okay, do I have to import something to use a function? Let's see. Import, okay. There is a standard library for array methods. Okay, so let's import that. Let's see if that makes a difference. Okay, so I guess that's how you import some from the standard library. Okay, that compiled fine that time. And there we go. Okay, so that 1, 2, 3, 4, 5, and then it goes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can there's methods for working with arrays, but that's not the only collection. You also have lists. So let's kind of go over here. Collections. Here we go. So this lists, again, they're going to be like arrays, and they work pretty straightforward, except now you're just using the word list, and then you have to declare like what type of data is in the list. Okay. So you can see here, list of integers. Can I declare without the typing? I do implied typing here? Okay, now this is just like some operator, so you can concatenate to the list. I remember seeing this something like this in kind of like in Lisp. I remember that confused the bejesus out of me. But essentially what this operator is doing is just saying, hey, you're concatenating this. And the parentheses is like it's a function, so you're passing it an argument saying, okay, I want you to take this number and then concatenate this into a list. And then I want you to take this item and then concatenate the remainder into a list, etc. Okay, but otherwise it's just essentially like another way of having an array, except you can add things to it. You can grab things from the front and back. You have a lot more different methods. So you can see like here, there's like a bunch of different methods for lists and loop through them and whatnot. This is too exciting at the moment. Sets again are just essentially like arrays, but with no duplicates. So if you turn something into an array, okay, and then here's where we start getting to more interesting stuff. Oh, and there's also tuples. Tuples are another thing that's like an array or a list. The difference is that a tuple can hold different types, but it's still a fixed number. So I can hold like, a string, then a number, then a whatnot, but it's a fixed number of types. So usually we do this for like pairs of data, like a name and an age, but you don't want to hold it in a key value pair. Then you would use a tuple. Okay. But again, the benefit of having that sort of fixed length is you can allocate that memory sequentially. So you know that memory is going to be sort of like allocated sort of right next to each other. Okay, and then let's go to maps. Maps are going to be our key value pairs. So we just use map, and then you have to define the type of the key and the values. So they all have to have the same key. You'll have to have the same value. Like most languages, if you want like different properties that have different types of values, then you need to define an object. So you have to use classes. I think JavaScript's really like the only one. I guess Python dictionaries can do this too, but they're like the only one, and Ruby hashes, where you can really just kind of define a construct willy-nilly that's just kind of like has keys and values of all types. I mean, maybe Perl. I don't know. I haven't really delved that deeply into Perl, but I imagine that Perl might have something like that too. Cool. PHP as well. Okay. So again, here we just use the word map. So you can also do it implicitly. Okay, so you can just define it with a map straight up. And again, the idea here, this is going to look a lot like an associative array in PHP, speaking of, where basically you put the key and then you use an arrow to point to the value. Okay, so let's see here. How do we then queue up a value? Okay, it's just, so we'll use dot notation to access the property. So that's nice. That's more like a JavaScript object. I like that because I know in like languages like Python and Ruby, you have to use like, you kind of use like the arrayish type syntax in order to access the individual properties. So that's all well and good. Okay, it looks like, I guess we use the, I'm assuming the plus sign is like more of a way to concatenate. But yes, let's try this out. Okay, so let's say var Alex equals a map, and the map is going to have my name, and my name is Alex Merced, and the map is going to have my age, which is currently 36. Okay, and then let's print line, and then we'll use a formatted string again. F, the name is Alex.name, percentage, I want to say S for string, I'm going to assume. Okay. And we'll see if that works well that way. I'm not sure if that's going to work the way I'd like it to work. I might have to switch over to printf. But then here we'll do alex.age, and that's going to be percentage %d. That syntax highlighting has me a little concerned, but let's try it out. Do I get an error? Yes, I do. Okay, required int. 3 errors found. Okay, so we'll probably, to get straight to the point, let's just change these into F's. Get rid of these. And I will get rid of this and rid of this. And then we will do alex.name and alex.age. Okay. Still. Let's see here. Value is not a member of the Scala collection, immutable map. Printf. Let's see here. Set. So we have a map. Yes. Oh wait, but I can't mix types. Ha. That's why. I just had a whole discussion about that. And then there I am, mixing types. Like it's a tuple or something. Okay. So, okay, let's compile that. Oh, still don't like it. ¿Por qué? That was on my Scala collection. String. Age. Why don't you like it? 1, colors 2. Let's see, how are we accessing the properties? Print. Okay, oh, I do have to use the array-like syntax. Ha! So what's going on over here? Print line colors dot keys. Oh, those are methods. So this is a method returning an array of keys and a method returning the key, an array of values. Okay, I see. I see. Oh, silly, silly me. Got too excited thinking, oh, I can use dot notation with my key value pairs. So no, I still got to do this. Name, age, there we go. And there we go. So the name is Alex Merced, the name is 36. I should have included a new line character with each of these. Let me just do that. Okay, and then let's compile and run it again. The name is Alex Merced, the name, oh, the age is 36. Well, you guys get the idea. But essentially, that is how I would do that. Okay, so now just because I'm curious, I wonder if I did this. Control C, put this here. Control C, put this here. Because I want to see now that we crossed that bridge. Now if I did this, would this suddenly now work if I change this back to this style of string and then make this print line again? And then you got rid of that new line character because that's going to be automatic since I'm using print line. Okay. Does it let me compile? Error F, the name. Oh, I see, because I'm using double quotes inside of it, so I should probably use single quotes. Let's try that. Yeah, there we go. That might fix that up. 2 errors found. Okay, error conversions must follow a splice. Okay, conversions must follow a splice. Use for a literal. Maybe wants another parenthesis sign based on the error. Let's try that. If not, I'm gonna let that go and just chalk it up to having to use printf. Ah, okay, so that worked. Okay, so let's see here. So does that do what I think it's gonna do? Oh, but it injects the whole map. Interesting. Doesn't really understand that I want just the value. Do we have an answer for that? Let's go back down here. Okay, like there, they're just concatenating the strings. So that's fine. Can we see an example? I am curious and need an answer. Concatenating map values into a string in Scala. I need answers. Here we go. Let's see. Here's a flat map, list map. That. I think they're trying to do something different there. To merge two maps, combine separate list map, how to concatenate list letter values of a map. Learn Scala maps with examples, Scala string, creating a string, concatenation. Scala. It's actually Scala interpolation with maps. There we go. That's probably what I'm looking for. Okay. Use for appending. Let's see here. Value. Value is. Oh, interesting. Wrap it in curly brackets. So let's try that. Okay, so if I were to wrap this in curly brackets and wrap this in curly brackets. Let me just make sure this is Scala we're talking about. In Python, the string interpolation can be done many ways. I tried it in Scala. Okay. Let's just give it a shot. Unclosed character literal. Actually, in that case, do I need this anymore? Let's see here. And then, let's see here. Let's change these back to quotation marks. And let's try. Aha! Compiled. The age is 36. The name is Alex%. There it goes. So we just have to wrap it in curly brackets. So that's how we would do it for a map. We would just wrap it in curly brackets so that we can capture that whole value. So then that starts looking a lot like JavaScript type interpolation, except you still need to include this thing after it. Okay, cool. Very cool. Okay, so I'll leave it at that. I'll see you all later. You guys have a great day and enjoy.